So with the next one, right, we are looking at this last one, HQG. So they want us to get the equation of HQG in the form y is equal to mx plus c. So, well, okay. It's a straight line.
Isn't it the same thing again? Because you
More or
got,
less.
yeah, because you got the gradient.
Well, we need the gradient, you mean, right?
Okay. So can't you use your 3/4? Is that for a different line?
Oh yeah, we can definitely use the 3/4 to help us get the gradient of HQG. Because what we know is, remember, we know that we have the gradient of this line here. We worked it out. And we also know that the line is perpendicular to our tangent. You know, so that's like information that we know. So let's see. HQG, let's see. So it's like 4 double I, so it's like 4II, right? Wait, no. Let's remove this. 4II. What do you have now? Yeah, HQG in the form this. So we said the gradient, we're gonna get it from this formula here. Where is it? This one. Because we know that if lines are perpendicular, their gradients multiplied give you -1. So the gradient of the first line multiplied by the second one give you -1. So the gradient of the line PQ, we know it is just 3/4. We worked it out, right? So 3/4 here multiplied by the second gradient is equal to -1, and then divided by 3/4 on both sides. What do we have there? We are having let's see.
Lever, the reason why you do this is because you actually working with another line. So you're working with the same, sorry, quickly go back to the picture. So you're working with the same PMQ, but you want to calculate the gradient of HQG, which is not the same as ERF.
Yes. Because the thing with ERF and PM is they're parallel. So with parallel lines, whatever gradient is here, it's automatically the same there. But these are perpendicular lines. So whatever gradient is here, if you multiply it with the one we don't have, we know it should be equal to -1. So that's how we're able to get the fact that the second gradient we're looking for is just -4/3, you see. So with parallel lines, we know gradient of one line. Where did we write it down? I don't know if we wrote it down anyway. But then with parallel lines, we know that the gradient of one line is equal to the gradient of the second line. This is for parallel lines, you see. And then for perpendicular lines, we have this formula here. Perpendicular lines. You see, they are both seen as gradient formulas. So what we said was, in the previous question, we just had to worry about getting this gradient directly, because whatever it was here, we automatically knew it was the gradient over there. For this question, HQG, we can get it by using this gradient because they're perpendicular. So as long as they're perpendicular, we can use this gradient formula, because in this gradient formula, we have something to throw in there. We can put the first gradient, and then that formula will give us the second gradient. You see? Yeah. Perfect. So what that means is in our equation of a straight line, we're gonna have the y minus y1 is equal to m x minus x1. So the gradient here is gonna be like -4/3. And then we need a coordinate that the line passes through. Oh yeah. I was getting too carried away. So a point that the line passes through, we have 3 of them. But it doesn't look like there's like a very straightforward way of looking at it. But then let's not be too closed-minded, right? Let's look at our image nicely. We have here 3, coordinate 4. We have here P, Q, blah, blah, blah. We need a coordinate that the line passes through. Which coordinate do you think we can easily find? G, H, or Q?
Well, we have
But yeah, just pick one, like amongst the 3, H, Q, or G. Even if
I
you're
would
just thinking
say Q would be easier.
Q. Okay, so now that we have identified Q would be easier, the next step is to look at our sketch, because remember, anything you're going to use to get Q, it has to come from the image that you're using. So even if it's a matter of going in your brain and saying, okay, what do I have on this sketch? I have this. That's one way to look at it. So we need Q, and Q is a point on 3 things. It's a point on the circle, it's a point on this line, and it's a point on this line as well. So what can we do to get Q?
So you could either label that as X and Y and use the midpoint theorem to calculate that.
Yes, there we go. Oof, nice, nice. Definitely, because we have a point that is in the middle, and we have a point that is on the other side. You see. So what we can do is we can use the midpoint formula, as you said, 100%, 100%. That's being resourceful, because it's not limiting our question to what is asked. They asked for the equation of the straight line, but we have to expand our thinking to using many different things, many different formulas. So in our case, we have point P, which is like, no, that's not P. Yeah, it is P, -1 and 1. So it's like -1 and 1. Then you have M, which is the midpoint, 3 and 4. And then you have Q, which we have nothing else. You see? So as you said, we can just use the midpoint formula. So the 3 is equal to this plus that over 2. The 4 is equal to this plus that over 2. You see, the midpoint formula. The midpoint formula just says your midpoint, you'll have x1 plus x2 over 2. y1 plus y2 over 2, you see. Yeah. And then you're going to have here an x value of the midpoint, the y value of the midpoint. So we have x equal to this, y equal to that. And then solving that, we're going to multiply by 2 on both sides, right? It's going to be like 6 is equal to -1 plus x, like that. The 1 goes to the left. You're going to have like 6 plus 1, which is like a 7. And then let me multiply this by 2, multiply this by 2. That's going to be like 8. It's like 1 plus y, 2. The 1 goes to the left. That's going to be like a 7 also, coincidentally, as it seems. So this is 7, coordinate 7. Yeah, it kind of makes sense, because if the y value up here is like 8, this one looks like it's a bit lower.
Yeah.
If the x value here is a 3, this one looks like, yeah, 7 is accurate. So let us carry on. So we have now the coordinate of Q, right? Perfect. So therefore, Q is 7 and 7. So now we can use our straight line equation, so y minus y1, I keep rewriting it, which is interesting. So it says here y minus 7. The gradient, we got it as oh, I was writing it up there. Should have just carried on. But anyways, it's -4 over 3. -4 over 3. Then that's like a 7. Yeah. And then this is like -4 over 3x. Then positive 28 over 3. Like y minus 7. And then this is like -4 over 3x. And then positive 28 over 3. Positive 7. And then this is like what? 28 plus, let me just check what that
It's
is. Do I have another calculator?
49 over 3.
9 over 3.
49.
29 over 49 over 3. Oh, thank you. 49 over 3.
Yeah.
Great. Great, ma'am. Great. We love to see it.
That makes
Okay.
sense now. Okay.
Yeah, it's quite interesting. Like it's amazing. It's amazing. It's amazing.
Yeah.
So you mentioned that